Hi everyone, welcome to Simple Chem, an online coaching for chemistry PGCT exam 2020. Here is the volume 1 question and answer. We covered these topics. First question, in Schrodinger wave equation, psi and psi square represents. The psi represent the wave function and psi square represent density of the electron. When L is equal to 3, the orbitalis, we all know that L is equal to 3 means it's azimuthal quantum number which represent the f orbital. The Hofbauer principle is not obeyed in. Actually, the Hofbauer principle will not be obeyed in chromium and copper because due to stability, the electron shift takes place from 4s orbital to 3d orbital in both copper and chromium. The orbital notation for L is equal to 3 in L1 and M is plus 1 is actually represented by 3 orbitals px, py, pz, and the magnetic quantum will be minus 1, 0 and plus 1, and M is equal to plus 1 will represent pz, that is 3pz. Which among the following gives least energy? According to n plus L rule, the 4s and 3p have the value of n plus L is equal to 4, but due to 3p have the n value 3, 3p has least energy. Match the following. Here is the match the following. 2n square which represent maximum electrons in the shell. The shape of d orbit is dumbbell in shape, and Pauli's will say that no two electrons have all quantum number identical, and according to our principle we have to follow n plus L rule. A 3d electron specify L is equal to of have azimuthal quantum number. Don't go with anything with S values. They concentrate on D, where D means L is equal to 2. That's it. For given value of principal quantum number, the ionization energy psi are 4. As we know that the ionization energy is maximum for those which is nearer to nucleus, hence the S electrons. These are the isoelectronic sodium, magnesium, aluminum, silica. Their ionization energy will be, it is the ionization energy with the ionization radius. So it will follow the order. Sodium is highest, then magnesium, then aluminum, then silica. Isoelectronic ions, those which have same electronic configuration, are called as isoelectronic ions. Among the third ionization energy is highest for. The ionization energy is most maximum for magnesium and beryllium because when 2 electrons is removed, it will attain noble gas configuration due to smaller size. Beryllium has highest ionization energy among the following. Screening effect is not observed in which of the ions? In all the above, the screening effect will not observe because all those have only one electron in each orbit. It is a problem, and when you solve the problem for relative error, it will give that the measured value minus true value divided by true value, and we get the answer of 1.1%. Formula for F test for different standard deviation is, as we know that formula will be S standard divided by S observed whole square. Next question. Intrinsic semiconductor room temperature will have what available for conduction? We know that both electrons and holes will be available because intrinsic semiconductor is a pure semiconductor. Only crystallographic defects or electron excitation can bring the conduction. As the temperature of semiconductor increases, what will happen? As the semiconductor temperature increases, the conductivity increases because the electrons in valence band can easily move to conduction band. As the temperature increases, electrons move from valence band to conduction band. There will increase in conductivity when temperature increase. Which of the following elements belong to same group? As we observe in the silicon and germanium, the answer will be the carbon, which belongs to same group of silicon and germanium. In order to obtain P-type semiconductor, the germanium should be doped with, as we know, it will be doped with trivalent because P-type means hole is the charge carrier, and here we create hole by trivalent impurity. How does a semiconductor behave at absolute zero? It behaves as insulator. Which one of the following elements is likely to participate in hydrogen bond? And we know that the high electronegative and small size and having 3 lone pair alpha fluorine is likely to participate in hydrogen bond. Which type of hydrogen bond present in orthonitrophenol and paranitrophenol? And you observe the orthonitrophenol. Here the hydrogen bonding is intra, means within the molecule. In paranitrophenol, the hydrogen bonding between two nitrophenols. Alkali metal in liquid ammonia are blue in color because due to the formation of an ion pair is formed. That is, a cation and the anion both will be formed. Hence, alkali metal give blue in liquid ammonia. Which of the following metal does not impart color to the flame? We all know that calcium, strontium and barium will impart the color. Magnesium does not impart the color, and here are the alkali metals which impart the colors. In diboron, what will you observe? It is isoelectronic in nature with C2H6 2+ and boron atom linked through hydrogen bonding. And this bond is 3 center 2 electron bonding. It is also called as banana bond. A true statement for azide is it is pseudo-halogen. Oxygen state of N in this ion is +1. As we know that it's a linear in nature, first option ruled out, and it is not isoelectronic with N2O. Thanks for watching Simple Chem. Told your friends to join us. Thank you. All the best.